Hey y'all, in this lesson, we're going to talk about the fundamental counting principle and the factorial. In my last lesson, we used a tree diagram to list out the possible outcomes of a college student's outfits that she wanted to take to a dorm room. And we counted those up and found that there were 36 possible outfits. And I mentioned that there was a little shortcut for us to be able to find that number. And today we're definitely going to be going over that. This is called the fundamental counting principle, and it works for any number of choices when it doesn't depend on the previous choice. So, basically, what you do is you take the number of choices in each step and you just multiply them. So we find the product of the number of choices in each part. And that means for the outfits, I have a little typo here. I had pizzas. Pizzas works too. It would be pretty cool. You can do like different types of crust and different types of meat and so on. But we did outfits. So if we go up here and we look at each part, in the first part, she had 2 choices. In the second part, she had 3 choices, and then 3, and then 2 again. Now, if we multiply all of those, we get 6 times 6, which is 36. So that was a whole lot faster and a whole lot less work than listing out all the outcomes in the tree diagram. Now, if the point of the question is to list out the outcomes, then the tree diagram makes sense. But if the point of the problem is to just find out how many choices there are, then using that product would have been a little bit faster. 3 times 2 gives us 36 possible outfits for her wardrobe. Now, if there is a restriction, we have different guidelines that we have to follow. So this was where, each choice didn't depend on the previous choice necessarily. So I want to go down here. I'm going to come back to this question, but I want to start with a simpler one first. And this is also going to introduce the idea of a factorial, the definition of a factorial. So if we use first the idea of the fundamental counting principle to figure out this problem, that's going to help us with the next ones. So we're using the FCP to find the number of ways you can write a 4-digit number using only 5, 6, 7, and 8, where no numbers repeat. So this is going to change the number of options we have in each step. And the easiest way I found to do this is kind of create a blank for each digit. We know it's a 4-digit number, and we're only using these numbers as our options. So in the first digit, the first part, we only have 4 options. And then it's non-repeating. So whatever I used in the first digit, I cannot use again. So now I have 3 options. And then I have 2 options. And then I have 1 option for my last digit. So using the idea of the fundamental counting principle, I can multiply my choices in each part. And I get 24 different outcomes. And then this also introduces the idea of the factorial. And the factorial is the product of descending consecutive numbers. So 4, 3, 2, 1. I could label this as 4 factorial. And a factorial is an exclamation mark. So it looks like you're yelling 4, but it's read 4 factorial in mathematics. So I want to quickly go over here. By definition, 0 factorial is 1. And this might seem counterintuitive because 0 times anything is 0. But if we're talking about the number of ways that something can be arranged, like the 4-digit number, how many ways 5, 6, 7, 8 can be arranged, then if we have nothing being arranged, there's only one way we can arrange that. And so by definition, 0 factorial is 1. So I want to go back up here to this example. I didn't want to start with it because it's a little bit harder to grasp initially. But now that you've been introduced to the subject, I think we can confidently go over it. So this has restrictions, several restrictions, and we have to eliminate choices along the way, like we did with the 4-digit number, that example we just went over. How many non-repeating odd 3-digit numbers are there? So the digits cannot repeat, which puts restrictions on our options. And it also needs to be an odd number. For something to be an odd number, that means that the last digit is odd. And so that's going to kind of decide my other choices, because if the last digit is odd and it's non-repeating, then that means that the first 2 digits cannot be odd. So let's see, how many odd numbers are there? If we think about odd numbers, there's 1, 3, 5, 7, 9. Let me list those out. 1, 3, 5, 7, 9. So there are 5 odd numbers that we can use. And then I'm going to draw blanks here so that I can list out my choices. And I'm going to call this my 3rd digit, my 1st digit, and this will be my 2nd. And I'll explain why I went in that order. So for my 3rd digit, I only have 5 options. Now I went to the 1st digit next because it's going to have an additional restriction on it. If it's a 3-digit number, then the 1st digit can't be 0, because if it were 0, then it wouldn't be a 3-digit number. So I have to eliminate 0 as an option. So, okay, let me write this out actually. Back up. If I consider all the possible digits, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I actually have 10 options, but I have to eliminate 0 as one of those options. And it's non-repeating, so whatever number I picked for the last digit, I cannot use, which means that I have 8 options for my 1st digit. Now let's talk about the 2nd digit. The 2nd digit can be 0 because it's in the middle, so I have 10 options there. But I already used one of the digits for the odd number, and I already used another of the another of the numbers for the 1st digit. So I, again, have 8 options for my 2nd digit. So here I am discounting, I'm eliminating any even numbers. Here I'm eliminating 0 and one of the numbers that I already used. And here I'm eliminating whatever numbers I used in the first 2 spots. So that's how I got to those numbers. And then for your last step, we just multiply 40 times 8 would be 320 odd, non-repeating odd 3-digit numbers. So you kind of have to, it can help if you list out those options and then think about, what you've already used, and that's going to help you decide what goes where there. So I want to go back to the factorial. We're going to be using the factorial a lot in this course, especially in this chapter, because factorials are going to be used in this next example, distinguishable arrangements, and then later in permutations and combinations. So we're definitely going to be seeing this again, and I just want to practice a little bit with the factorial. Remember, the factorial is the product of descending consecutive numbers. So 3 factorial just means 3 times 2 times 1, and that is 6. 3 factorial equals 6. Oh, my box got ugly. Let's fix that. There we go. Now 5 factorial is 5 times 4 times 3 times 2 times 1. And you can type that in your calculator if you need to, or you can use commutative property or associative property, kind of rearrange and group. We've got 20 times 6 is 120. So now we have several different things going on down here. And we are going to consider order of operations. So before we can deal with the factorial, we need to simplify what's inside the parentheses first. Then, oh my, I think my sleeve is causing it to go up and down like that. Then you just multiply. So 5 minus 3 factorial is just 2 factorial, which is 2. Now I want you to try these on your own. Now that you know a little bit about the factorial, try it on your own, pause it, try it, come back and check. You'll notice in this next one that 5 factorial minus 3 factorial. Again, we want to use order of operations. So this is kind of hidden multiplication, and we want to deal with that first, then subtract last. And coincidentally, we already figured out what 5 factorial was, and we also figured out what 3 factorial was. So I just subbed those in, subtract. So you can see that 5 factorial minus 3 factorial is not equal to 5 minus 3 factorial. It does matter where those parentheses are, where the factorials are. So just be very careful in how you go about tackling those problems. This last one, we can do it two different ways. The first way is to use substitution. We know that 5 factorial is 120, and we know that 3 factorial is 6, and we could just divide those. Or another way, which is going to be helpful as we learn more about factorials and use them, is if we were to write this out in expanded form, 5 factorial over 3 factorial. Now these are all joined by multiplication, separated by division. So since it's like that, I can go through and divide common factors. So 3 is going to divide by 3. 3 divided by 3 is 1. 2 divided by 2 is 1. 1 divided by 1 is 1. And we're just left with 5 times 4, which is 20. So in either case, you're going to get the same answer. It doesn't matter which way you approach that. I just wanted to show this because it's going to come in handy later. So we have an example down here where we're going to be using factorial. Ashley has 6 different spices she wants to place in her cabinet. How many different ways can she arrange these spices? So if she has 6 different spices, then you can kind of picture her cabinet. That means she has 6 different places to put those spices. In the first spot, we'll call this the spot, she has 6 spices to be placed there. In the second spot, she's already put 1 spice in its place, so now she has 5 spices, now 4, now 3, now 2, now 1. Or we could write that as 6 factorial. And then I want to show you a little shortcut here. As always, love to use the calculator. If you want to pull up a factorial in your calculator, I'm going to type in 6 first. And then I'm going to go to math, over to probability, and you can see number 4 has the factorial there. And there you go. Or you can type it in the long way if you want. 6 times 5 times 4 times 3 times 2 times 1, 720. So either way, we're going to get 720. 720 different ways she can arrange those spices. Last example here, arranging objects with repeating kinds. We have this little formula here that you're going to use if there's repeating parts or repeating kinds, like I said here. You take the total number of objects, factorial, divided by the number of times that each object repeats, factorial. So famous example here, you can use Tennessee or Mississippi. I used Mississippi. We want to know the number of ways that we can arrange these letters. And there are repeating letters in this word. So we're going to use the formula above. The total number of letters are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So many. divided by, and I did a long bar because there's going to be several things in the bottom. I repeats 1, 2, 3, 4 times. S repeats 4 times. P repeats 2 times. So I want you to be very careful here. If you're typing this in the calculator, just make sure that you type it in correctly, because your calculator is only as smart as you are. We're trying to tell the calculator this is in the numerator divided by this is in the denominator. All of those numbers are in the denominator. So be very careful with that. If you're doing it by hand, we can expand out 11 factorial, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, very long. And then we can expand out each factorial in the denominator, 4, 3, 2, 1, 2, 1. And now we can go about simplifying. And it's all multiplication in the top, all multiplication in the bottom. So now we can start dividing these factors that repeat. So those are gone. And then we can start reducing if you want to. I mean, you could multiply all of this and multiply whatever's left over down here, or we could reduce further. For example, 6 divided by 2 is 3. 8 divided by 4 is 2. And then these 3's go away. You can see how this gets a little bit messy. I wouldn't necessarily recommend it, but if you can stay organized, that's the key. Stay organized and you can do it. Now you can see here that I've effectively eliminated everything in the bottom except for ones, which is nice. And then in the top, all I have left is 11, 10, 9, 7, 5, looks like. So I'm multiplying 11, 10, 9, 7, and 5. That's a little easier than multiplying all those numbers and then just multiply it out. You can see in my calculator here, I did the second line on the calculator has 11 times 10 times 9 times 7 times 5. That's for when I did it by hand. And we got 34,650 ways to arrange those letters. And then in the next line, the last line here, I wrote out the formula instead. And so you'll notice that I did use parentheses there because it does matter. Your calculator is going to need those. And then for every single factorial, you have to go in and grab it. So parentheses, that's numerator 11. Then you go to math, probability, factorial, close it, divided by parentheses for the denominator, 4 math, probability, factorial, 4 math, probability, factorial, 2 math, probability, factorial, close it. And that's how you get that. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.